Good morning, everyone. This is the first time, our first lesson, right? Um, if you have me in the past, of course, I have done video recordings before, but this time I did it where you guys can see me talking as well as writing under the doc cam here. So the other thing about doing it this way, since I am videotaping myself on Zoom, you get to see and hear all of my mistakes, just as if I was teaching in front of you, okay? Remember that when you are taking notes and going through, if you have questions, write them down so you can ask me the next day if you don't want to ask me right at that second, okay? So as you can see, our first chapter is actually chapter 0 because this should be all the review from last year or the last couple of years. Now, again, because last year was kind of crazy, there might be things that you don't feel comfortable yet. Just make sure you communicate with me so that way I can give you the support you need, okay? Plus, the great thing about the video is you can always go back and watch it again if you need to, okay? So let's start off. The slope of a line is symbolized as the letter M. We should have known this for the last couple of years, right? Especially when we do slope-intercept form. So I'm just going to highlight that to keep that in mind. M means slope. The other thing we know about slope is it rise over run, or we've seen it as y2 minus y1 over x2 minus x1, or delta y over delta x. Okay, so remember y over x, it's that change of the rise over the change in the run. And be careful of your positive negatives, okay? So we're just going to go through examples so we remember how to do this. So when we have graphs, of course, the first thing you're going to do is find 2 points that really go through coordinates there. So we already have the dots there. So we create that right triangle, and we see we're going down 1, 2, 3, 4, down mean negative, and then to the right 1, 2, 3, right is positive. So that means for number 1, our slope is negative 4 over 3. Okay. Now 2, we have 2 coordinate pairs. Okay. So remember, we're doing our y's over our x's. So does it matter which y you put first? No, but you do have to make sure that the x is in the same thing. And I'll show you right now on the paper. So I'm going to take this y here. So I'm going to go 0 minus, and then the second y is 2. Now, because I used the 0 first, that means for the x value, I must use that one right there, which is negative 2. So negative 2 minus 4. Okay. And when we simplify that out, we get negative 2 over negative 6, which of course is positive 1/3. One thing, as you can see, what I'm doing here is I'm doing this equal sign but with an arrow. The reason being is I want to get you in the habit. So what I didn't like about this book right here is when it had all these equal signs in the same line. That is actually not allowed on your test. You could get a point taken away because you did this. It would have been better if it was equals M, which equals rise over run, which equals so on and so on. Okay, so if it's a vertical, it's fine. Horizontal, it's not. But if you want to get away with horizontal, you can put this arrow here, and that covers it. Okay, so if we had done 2 first, and we said 2 minus 0, we would have gone 4 minus negative 2, which if you try that out right now, we would still get 1/3. So let's try that again. So we have 2 minus 2, because those are our y's, right? all over. And since they're both the same, it actually doesn't matter which one of these we put first. So I'm just going to go in order 3 minus 2. So when I do this, guys, just to not confuse myself, as I usually just keep the first point in the first one. All right, 2 minus 2 is 0, and 3 minus 2 is 1. Well, guys, 0 over 1 is 0, and I need you to define that. Don't keep it as 0 over 1. Put it in as 0. All right, next one. So we would have 2 minus 5 all over 3 minus 3. So when we do that out, we get negative 3 all over 0. Well, can we have things and divide them into nothing? No, we can't. So this answer is undefined. And usually for undefined, we can put UND. These two are very big. I've seen multiple kids confuse these two. When zero's in the numerator, it's 0. When zero's in the denominator, it's undefined. All right, let's do a little bit of vocab here. So parallel lines. Parallel means that they are equal. So if we talk about parallel lines, the slope is equal. If we talk about perpendicular lines, that means the slope is opposite reciprocals. Okay, so opposite, so one's positive, one's negative, and reciprocal is you're flipping that fraction. Okay. Other vocab that we need to know, the types of lines that we can make. We are used to this point slope form. The reason why it's point slope is the point is the y1 or x1, y1. And the slope is the m. That is the easiest form. Now, slope-intercept form, of course, there is your slope right there, m, right? Your slope is m. But in this case, b is your y-intercept. And if you remember, the y-intercept is a coordinate where x is 0 and y is the number, okay? And that would be your b. And then there's general form. The other way you guys have heard general form is standard form. It's where you have ax plus by plus c. A, b, and c are integers. So remember, integers are whole numbers, positive and negative whole numbers, okay? So keep that in mind. We're going to go through an example like this, and I'll keep going until we get to that general form. So make sure you recognize where we're supposed to have it. So number 5, first of all, it says find an equation. So that means we could do any of these equations, okay? Because it's not specifically telling us what to do. So number 5, a line through 2, 3 with the slope of m equals negative 3. Well, we have a point and we have a slope. So can't we just use point slope form? Yes. Sorry guys, that was my light, so now I'm in the dark. All right, so we get y minus y1, which in this case is 3, equals, and then we have our slope comes next, which is negative 3, times x minus, and x1 is 2. And we are done. Okay. Now, the biggest thing that you're going to have to get used to with calculus is that you don't always have to have it in simplest form unless it requires you to, or if it's a multiple choice question. So throughout these years, teachers have been asking you to reduce, 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 but you don't always have to reduce. And it's going to be hard to get used to, but I'll point out when it comes where you could have stopped. All right, vertical line. Well, let's think of this. If we have an XY axis, our vertical line is a line that goes up and down, right? Up and down. So what value are we actually looking at? If you look, This axis is the x-axis. So we are looking at where x equals. Well, if you look at the coordinate, x equals -1, and that is our vertical line. Okay. All right. Now, I'm hoping I have enough room for these. Number 7, a line through the point parallel. Let's look at that. What does parallel mean again, guys? Parallel. Remember that parallel means same slope, right? So I'm just going to remind myself, same slope. Okay. To the graph of 2x minus 5y equals 5. Now it's saying that you want your answer in slope-intercept form. So we need to make sure that our answer is that way because it's asking for it. Well, here's the thing. If I need the same slope, this is not in a slope form. So I'm going to have to get it there. One of the ways to get a slope is to solve for y. Okay, so that's the first thing I'm going to do is just solve for y. So I get -5y equals 5 minus 2x. I got to divide everything by -5. Okay, so I get y equals, well, 5 divided by -5 is -1. I'm actually going to put that on the other side and put the slope in front where we're used to it. And -2 over -5 is a positive 2/5. And don't forget that x. Since we put it in slope-intercept form, now we know the slope. The slope is 2/5. Okay? All right, so it's parallel. So we know we're using that slope, and we know it goes through this point. So the first thing we're going to do, second thing we're going to do is put this in a point slope form. Okay, so just like we did above, it's y minus y1, which is in this case 2, equals the slope 2/5 times x minus x1. Well, I would say a minus -1. Well, what's a minus -1? It's a +1. All right, one more thing, because we're tempted right now to stop. We've got our parallel line, but this is in point slope form. We need to change it into slope-intercept. So what we're going to have to do is distribute this out and then move that 2 over. So let's distribute the 2/5 out first. So y minus 2 equals 2/5 x plus 1. Now I got to move that 2 over by adding. So that 2/5 over x, 2/5 x stays the same. And I'm adding 2 to the 1. So I get 3. Oh, I made a mistake. What do you know? I distributed that out, but I didn't distribute it out to both. Mistake on my part. So let me go back. 2/5 times 1 is 2/5. Okay. So what I'm going to do in this case is either I can do this by hand and keep it in, use your calculator, do it by hand, or guess what? Guess what's the easiest thing to do, guys? If we're going to add 2 to both sides, why can't we just say plus 2 and 2/5? Kind of crazy, because in the past, your teachers never let you keep it like that. They wouldn't make you change it to an improper fraction. But this is the correct answer. You get full credit for this because it's in slope-intercept form. Okay? Tricky. All right, number 8 here. So we have a line through the same point, but we're dealing with perpendicular. Well, what I want you guys to notice is that we have the same point and the same equation. So we don't have to rearrange it again because we already did it right here. So since we know that the slope is 2/5. And we want it to make it perpendicular. That means the second slope, and I'm just going to put a 2 here so we know the second slope is the opposite. So this is positive, so this one is negative. Reciprocal, so I'm going to flip that fraction to 5/2. Okay, now I can put it in point slope form. So I'm going to put a 2 here. So y minus 2 equals negative 5/2 times x plus 1. Okay, good. But we need it in general form, so we're going to have to distribute, and then we're actually going to move everything to the left side. And no fractions, so let's keep that in mind. General form means integers, right? Integers, so no fractions. So let's see what we have to do first. Let's distribute, and let me remember to distribute all the way this time, right, guys? So negative 5/2 x minus 5/2. Okay, so we could move everything over like I said, but really what would be easier to do is to get rid of the fractions. Does anyone remember how we can get rid of these fractions? Hopefully you were thinking we can get rid of these fractions by multiplying everything by the denominator we see. The denominator we see is 2, okay? So I'm going to make an arrow because lots of times when you have a lot of work going on, you want to be able to find your work. So I'm going to do an arrow so I know where I'm taking my next step. So if I multiply everything by 2, I get 2y minus 4 equals negative 5x minus 5. Now I'm going to move everything over. And if you guys don't mind, I'm going to move everything over in one step just so it's easier to get this work done. So I'm going to put it in order 2 of x, y, and then constant. Okay. So if I move the x over, I get positive 5x. The 2 is on the correct side already, so 2y. And then I've got to move this 5 over. So I'm going to add the 5 over. Negative 4 plus 5 is 1. And that would equal 0, and we have it in general form. All right. Next, just drawing. So there are 2 methods with this. Many of you probably look at this equation and say, hey, we have to solve for y first and get the slope and the intercept. And yes, we can do that. We can do that just fine. But there's another easy way to do this, guys. When drawing a line, how many points do you need? You need 2 points. What are the easiest points? X and Y intercept. So the first method you can do is just X and Y intercept. So we could say 2 times 0 plus 3y equals 9. So when x is 0, y has to be 3. And do the other one. 2 times x plus 3 times 0 equals 9. So x is 4.5. So 1, 2, 3, right there about. We'll just do it that way. Let me get my ruler. Okay. Now I will show you the other way. This is going to be up to you guys, okay, of which way you want to do it, how much time it takes you, so on and so forth, okay? Now, in the second one, if you put it in slope intercept form, you just have to solve for y. So the first step you would get is 3y equals 9 minus 2x. Then divide by 3, so we get y equals, I'm going to rearrange it into slope first, okay? So negative 2/3 x plus 3. And so we can do this by graphing the y-intercept and then going down to over 3. And as you can see, mine's a little off, but because we estimated what that was. So a couple of ways. Okay, next one, y equals 2. Okay, above, we did an x minus x equals -1, and that one was vertical. So what we need to keep in mind is when it's y equals a number, it's a horizontal line. Okay, so all we have to do is find out where y is 2, and then we know it is horizontal. Now, everything we've done on this page, guys, you should be able to do without a calculator. Okay? The reason why I say this is because a bunch of the calculus stuff is either calculator or non-calculator. You need to make sure that you can do the non-calculator without a calculator. Okay? So we got a little bit more here, and then we're done. So what I need you to do is make sure you have your calculators out in front of you, because that's what we're going to do. Okay? So it says here, find a window to show the complete graph. Think about what complete graph means. So what I'm going to do is start you off with your basic. Okay, let me make sure my window is fine. So this is a basic window, a 10 by 10 window. So what I'm going to do first is actually put in this function. So -0.2 x cubed minus, make sure you say minus and not negative, 2.2 x squared plus 1.6 x plus 1. Okay, I want to make sure I have that all in it and correct. Plus. Okay, minus, good. That one's a negative, great. So when I graph it, let's look at what happens. Do you think this is a full graph? Kind of looks like that. But if you look at the function, it is a x cubed, right? Which is an odd function. And we remember, hopefully, that odd functions and behavior is usually one goes down, one goes up. If they both go the same direction, it should be an even function. So we know that we're missing part of the graph because one should go down and one should go up. Here's the other thing to analyze. It's negative. Okay. Now here's my issue, guys. You guys are watching me on the camera, but the camera shows a mirror and I don't want to mess with it right now. So let me make this note to you. So even functions, right, either go up or down. Remember, positive would go up, negative would go down. Okay. Now, sorry, it's blurry. I'm trying to get it to stable. If we do odd, remember a positive odd will start down and then go up. But a negative odd would start up and go down. Okay? So this is positive, this is negative. These are some side notes. Okay, it is negative. So that means that this side looks gray. What's probably missing is this side over here, okay? And if it comes up, that means we want to get that minimum value. So I'm gonna go more to the left and more down. So left means negative, right? More negative. So instead of -10, let's do -20. And we need to go more down, so let's do -20 here. Graph. Oh, well, I'm getting that other part. So as you can see, I don't have to go more left, but as you can see down here, I'm missing part of it, so we have to go more down. And this takes practice of like, how much do I go by? So I'm just gonna go by tenths until I get the perfect one. Yep, not there yet. So that was what, 30, -30. So let's do -40. And you could jump higher if you want, that's fine. Let's go -60. Let's jump to 20. Okay, So we've got our stuff, graph. Did we get everything? Do we have the end behavior, the max and mins? There's nothing else that could be here other than it keeping going on. Great. So we finally got it. So now what we're going to do is sketch it because that's what it asks for a sketch, right? And indicate the scale. So first thing I'm going to do is just sketch it out. Okay. I also know that this is really close to the x-axis there. And then it looks like it's right here at the y. Okay. Now, I am also going to label what my boundaries were. So if you remember on x's, we went from -20 to 10. Oh, I did that on the y's. So y's would be -60. Sorry, guys. To 10. And then -20 to 10. You need to have all the major things in it. If we forgot the min right there, we would not be having all the complete graph, okay? All right. Next, now that we have our graph, we can find the zeros. Well, let's remember what the zeros mean. The zeros means where it crosses the x-axis, okay? Now, also, so what I want to point out is that 0 means that f of x equals 0. The great thing about zeros is you only have to have the x coordinate because you already know the y coordinate 0. So let's remember how to do that. Let me go back to graph. And what we do is we go second trace. We go down to 0. That's kind of awesome, right? Enter. And then we got to get really, see how it says left bound? So you're going to be on the left side, which means left side is actually above it. Enter. Go below it. That's the right side. It says guess. We need one more enter. And we get -11. Okay. Now, here's one thing that's major in calculus. You have to go 3 decimal places out. If you do not go out 3, you get points taken off. Okay, so we need to practice that. So the first 0 is x equals -11.6. And then let's see, it says 498. Well, the 8 makes the 9 go to, all right, there we go. So that rounds it up to 0.650. All right, are we done? No, because we still have 2 other zeros there. So let's do that again. Second trace 0. Okay, and I'm gonna get close. All I'm doing, guys, is pressing the right button here for me to get really, really close. But remember, we're looking for the left bound of it. So I'm gonna get really close. Enter. Then I'm gonna make sure I'm on the other side of the x-axis. There. And I get that another 0 would be x equals -0.406. Okay, one more. So second trace 0, right? I want to be on the left side. Enter. Keep going to the right side. Enter. Enter again. And this would be x equals 1.056. Hopefully this sounds familiar because you've been practicing over a couple of years on how to find these things. If not, make sure you ask me questions. Okay. Find the point of intersection of these 2 graphs and write the equation you're solving. Okay, so when we're finding the intersection, what does that actually mean? It means where are they equal? So the equation we're actually solving is saying that -x cubed plus 12x squared plus 9x minus 3 equals. Uh-oh. I can't just put equals, right? Because that means I would have to have a y equals and a y equals. So what do I have to do? I have to rearrange that before I can put it in this equation. So I get negative y equals negative 3x minus 5, right? That's moving everything over, but I need to divide by this negative here, so I get y equals 3x plus 5, or plus 5 because I'm dividing by a negative. And then I move that there, so this is what I'm solving for. Okay. That's what I'm solving for. But now I actually have to find the points, right, guys? So we have to go back to our graph, go to y equals, and what you're going to do, I'm going to highlight this, is you're going to put one side of the equation into y1 and the other side into y2. Okay? Hopefully this sounds familiar. All right, so negative x cubed plus 12x squared plus 9x minus 3. So that's one of them, right? And I have to go down. So I'm going to press the down button and then type the other equation in, which is 3x plus 5. Now, because my window is still set to my other graph, when I graph it, I might not see what's going on here. Okay, so we're going to have to readjust this window. Now, when you're readjusting, as you can see, I can almost see the two intersections right there. But you also don't want to assume that there's only two, right? So I know I have to be up here somewhere. So I'm going to actually start at the negative 10, 10. Because then I can see what's going on and I can make a conclusion if I have to go further. Okay, so I see there's two intersections. This is great. But if we go back and we analyze this equation again, it is what? It's a cubic. But this graph looks like, it looks like a parabola, like an even function, right? So this is negative, so it should come back down. So I'm going to go over to the right and up. So the right, let's go, let's try 20. And let's go up to 20. See what happens. 1. Oh, and that's good there. 1, 2. Oh, it looks like it's going to cross over here. So you know what I'm going to do to make this nice, guys? I'm going to get these two and then go all the way up there. So it's not all crowded in the graph. So to find the intersection, second trace, intersect. Now the great thing about the intersect is all you have to go is close to the intersection. Let me see where my star is. Okay, right there. So by the way, I couldn't find my star at first, and sometimes it's because it's on one equation off the graph. So what I do is I press up or down. So watch, if I press up, it transfers to the other equation, but I can't see it. So I'm going to press down, and there I can see it. Now I'm going to move to the left and get very, very close to where they intersect. So that looks like where they intersect, right? But I can't trust that yet. I'm going to press enter 3 times. 1, 2, 3. And there is my intersection, my first intersection. Now, how many decimals? 3. And because we're talking about an intersection point, you need the x and y. Okay. So if I left myself some room, I get negative 1.046, comma, 1.861. Okay, there's one. So I'm probably going to have to move on the side. Sorry, guys. Okay, I can do the other one. So second trace, intersect, and then, oh, that one will be fine. I still see it. Can you guys see it? It's flashing right there. 1, 2, 3. All right. So we get 0.615, comma, 6.84, and that 5 makes it go up to 6, so 4, 6. Okay? All right, next one. Sorry, my handwriting's bad. Now I need to adjust so I can get that one piece up there. So let's go window, and we need to go, let's just go more up. So let's go double it. Let's go to 40, see what happens. So there, we're looking for it crossing here. Oh, we're still going up, guys. Okay, let's go up more. Let's go to 70. See what happens. Now, I'm really glad that I found the intersections before right here, because see how crowded that gets? So I'm going to keep going up. What were we at? 70? Let's try 100. Oh, what am I doing? I meant up and I kept going right. Oh my goodness, guys. Mistakes. Let me go back to 20, because that's how that was. We were going up, right? So let's go back 40. Sorry. X is left and right. Y is up and down. Goodness. Okay, that's better there. Okay. Oh, we're almost there. So all I got to do is go up a little bit more. I hope some of you caught that before I did. I was wondering why I couldn't find it ever. Okay, so I went to 50, and look, now it crosses. Now I can find it. So second trace, intersect. I can't see my star, so I'm gonna press down, and now I see it. And I'm gonna go close to that intersection. 1, 2, 3. So there we go. We get 12.40431. I got a round, right? Comma 42.293. So 1, make sure you're going in the right direction, but 2, make sure you analyze the equation to see how many intersections you predict. So if this was an x squared, it'd probably be only 2, right? Because that's x squared in a linear. Could be 1, but it could be 2. Where this x cubed means it could be 3. So double check with your window. All right, one more and I swear we're done. All right, so we have an inequality here. Now, we can use our calculators just like we would with the equation, okay? So I'm going to do a y1 as that side and y2 as that side, okay? And again, my window is going to be off, right? So let me go to y1, clear it out, clear it out. Now, absolute value, depending on your calculator, you need to figure out where this is. And for us, on my calculator, it's math, and then I have to go over 1, and where it says ABS. Okay. Now I have to write in x squared minus 5. So x squared minus 5. And then my y2 is the value of 4. Okay. So enter. And then let me change the window so we're back to the normal. We'll see what happens with that window. All right, that looks kind of awesome there, right? All right, I'm going to sketch this out so we can have this discussion about this, okay? So if I have my x and y axis, okay, and we have our graph, which is kind of this W looking thing. You guys see that? Does that look okay? Okay. Now, we know that x equals 4 is going to be right here. You see that, guys? Now, greater than or equal to. Greater than, would that be above or below the line? Oh, and of course I drew my line too small. Okay, there we go. Okay, sorry. Okay. So above or below, greater than is above, right? So what I'm going to do is look at everything above, and I have this line here, this upside down pump, and this other line here, which means I am going to have 3 intervals, okay? What that also means is that I need to find out where these intersections are, because that will tell me the inequalities. So let's look at the farthest left. I know the farthest left will be negative infinity. And what's always around negative infinity? Parenthesis. Now, I'm going to do the intersection right there. So second trace, intersect. Going to get close to that intersection. 1, 2, 3. And if you see, it says -3. So negative infinity to -3. Question is there a bracket or a parenthesis around -3? It is a bracket. It is a bracket. Why? Because it's equal to. Okay, so that is a bracket. Okay, now let's do the other one. So second trace, intersect, get to that one. Sorry, 1, 2, 3. I get -1. Now again, -1 has a bracket because it's equal to. Let's do the other ones. Second trace, intersect. Okay, sorry that it's not focusing. 1, 2, 3. What'd you guys get? Hopefully you got 1. And then the last one, you see that we're going to find that one intersection, and then it goes to infinity. 2, 3. So 3, infinity. One more thing, guys. So in calculus, you should be able to go between interval notation, so this is interval notation, or inequality notation. So what does that mean? So we're going to learn that right now if you haven't done that in the past. So when I say that it's negative infinity to -3, what values are we talking about? We're talking about x values, right? The x values that we're talking about in this interval is where x is less than or equal to -3. Okay? Now this middle interval, what we're saying is that x can be what? X can be in between these two. So x can be between -1 and 1. Now again, it's equal to, okay, because of the brackets, because it's equal to. And the last one, x, in this case, is greater than or equal to 3. And you just did interval notation and inequality notation. Be ready to do both, okay? We are done with this lesson. Hopefully this seemed like review. I know it seemed like a long lesson, and that's because I like to pause and let you think. Make sure when you do your work, check your answers on the answer key and communicate with me how you're doing. All right, enjoy.